All right, perfect. All right, so I don't know about everybody else. So welcome in whatever time zone you're in. It's approaching 8 p.m. My time. I'm not sure about you. I'm exhausted. There's been so much stuff going on. I feel like I need Kubernetes for my brain. It's thunderstorming where I'm at. My neighbor is currently mowing. I'm pretty sure you're going to hear my dog bark. So if that puts anything into perspective, we got a lot to cover, and there might be some distractions. There could be some failures. Welcome to development in 2020. So expect very, very low expectations here. So I do want to talk to you about building and debugging microservices with Kubernetes and Visual Studio. We've seen a lot of stuff happen today, all the way from Brendan talking about what microservices was to Kelsey asking us what was the meaning of life. So I think that pretty much covers a really good conference so far. But I'm going to start off with, I think the question that a lot of us saw on many, many slides throughout the day. And that is, what is microservices? I think it's a question that everybody asks. I think everybody has their own definition. I'll give you mine. It is a kind of culmination of a lot of what a lot of the speakers said today. But the questions are kind of, what are they? How big should they be? And I joke, like, they're supposed to be small, right? I mean, it's micro. What tools do we have to kind of build and deploy and test and kind of manage all of this? And I think the bigger question is, should we just jump right to them? I think Brendan mentioned in his talk, like, are we just checking a box on a resume or a CV? So I think all of that, I hope you got a lot of those questions kind of answered throughout the day. If you missed some of those talks, certainly get a chance to look at them in the post recordings after we put them out there. So what I'm going to jump into right now is kind of my definition of what microservices are. And I think you saw some variations of these slides, so I'm glad they grabbed them from me. First off, they are around independent deployments and improved scaling and resourcing of the utilizations per those services. They allow for our teams to be smaller and focused on that one particular service and the deployment of that one service. And they also avoid single points of failure. Now, what does that really mean? That means that hopefully that one service, if that one service fails, it does not take that down the entire application. If it's a mail service or a messaging service or a notification service, it's okay for that one service not to work in the broad spectrum of the entire application. It should not bring down the world. I think we've all experienced at some point that, hey, my one connection to one external dependency failed, my whole app doesn't work. We just get a 404 or a 500 or something like that, and then we're getting calls. Hopefully that developing a microservices kind of architectural pattern eliminates some of those types of situations. And all of this really increases our velocity. One of the patterns of microservices is putting them in containers and allowing us to constantly do the CI/CD and deployment regardless of what the app is. Elton did a great job of showing how we can take a legacy app, a 12-year-old pet store application, putting it in a container and throwing it on Kubernetes. And by doing that, it allows us to put it in a Docker container and make changes to that app slowly, but allow us also to push it out to a cluster at a fast pace. Monolith applications, very slow moving type of velocity. This allows us to increase that velocity. And again, puts isolation around that one particular application, but also allows us to move forward on some future application development and some of the newer technologies while not impeding the application as it stands right now. Julie did a good job in her presentation around DDD and talking about the kind of boundaries of microservices. And I think this is a very important point when it talks about what are they and what should we put in them. And I think it also talks to how big should they be? And that's really up to you and your businesses. If I have something that does just products, I think, is it okay to say this just gets my products and just manages my services for my products? Great, then that is your service. It might have a database or a subset of databases or just tables. But you have to decide what is the boundary around your service. As far as how they communicate, they commonly communicate over the network using HTTP or REST services, gRPC, as James talked in his presentation. Super fast binary communication. That's really great when it's within a cluster because it's super fast. Don't have to worry about being human readable services as they're going across the wire. It's a great use of that service. Or event-driven messaging, as Clemens used in his presentation about just throwing messages around in queues and such. And then just at the very base of things, how do we package these up and get them ready for deployment? It is containers and using Docker type technology. So what I want to do first is jump right into demos. I think we like to see demos and see this stuff work. And the first thing that I want to start with is just what does Visual Studio offer us at the very base level of getting started with a microservice and also just Docker containers. We could jump right to Kubernetes. I think we should, but I'm going to show what does Visual Studio offer when we're talking about just maybe just an API, maybe just a web application, and at the very low level, kind of baby step into what our tooling right now offers us when it comes to getting started with microservice development. I think sometimes we jump kind of right into the pool with both feet without really understanding what is available to us. So let's jump into a quick demo. And what I'm going to do, I apologize for looking up. I've got a screen above my camera, so I'm not looking to the sky for thought. I'm actually looking at my demo. So let me, I'm going to open up just real quick. I just did a file new project. This is the weather template that's in our API. It should be pretty familiar to anybody who's done kind of file new project in .NET. And what I've got here is on the right here is just a web API. And I think if I F5 this, everybody has seen this. We've got some random weather results that's going to come through in our web API. So what I'm going to do to this is I'm going to right click, not deploy, because I've got some friends that would yell at me for doing that. I'm going to come down and go to add, and there's an option here called container orchestrator support. So what I'm going to do is I have some options now. I can choose Kubernetes and Helm. I'm not going to do that at this point because we're going to go later on in the project to show some of those things. But I'm going to choose Docker Compose and hit OK. It's going to ask me my targeted OS, and I'm going to choose Linux here, so I want to use Linux containers. And what this is going to do for me right away is it's going to inspect the application that I have, and it understands that I'm using a .NET Core application. It automatically adds a Docker file for me. It understands that I'm using Core 3.1. By default, it chooses Buster Slim, which is that Debian base image for Linux. And it adds that for me, which is great. Then it also creates a Docker Compose file for me and adds my project to use that particular file. So if I F5 right now, it would fire that up. That's not super impressive at the moment because it's just a single file. But what I'm going to do to this here is I'm going to go ahead and add an additional project. So let's add not a website. We're going to add a new project. And we'll add a new web application. We'll just call it web front end, I guess. Sounds good. We'll hit create. And we'll choose a web application. I will choose yeah.
You're still showing PowerPoint.
Oh, you know what? I don't hit escape. My mistake. Did I only share? Sorry about that, guys. You know what I did is I only shared PowerPoint. Are we good now? Yes, no?
Yeah, there we go.
My mistake. My mistake. I'll actually walk through that whole thing because I had to do it for another project. So what I did was is I right-click this project here. I did add, and I chose container orchestration support. So I'm going to do that for my web front end. I'm going to click add. I'm going to choose container orchestrator support. And I'm going to choose Docker Compose and hit OK. And choose Linux. And for my web front end application, it adds that Docker file as it's thinking. There we go. It adds the Docker file for me. There's my Buster Slim Debian-based image. And it adds that Docker Compose project. If I go to my Docker Compose, there was my web API project that I was speaking to earlier while you're looking at my beautiful slide. And now it's also added that web front end project for me in my Docker Compose file. So just so I can wire these up, I'm going to go into my web project, and let's go over to Pages. Let's go to the index file. And just on my on-get, let's add some pretty code here. And we want to call it Web API. That's what we want there. And let's make sure we get our all that there. Perfect. And then in the index, I want to make sure that I'm actually showing my message that I'm writing out there. Pressures of typing while everybody is watching. And there like Elton says, our snippets don't work all the time. There we go. So now what I'm going to do is in my project here, I'm actually going to hit the URI via the DNS that Docker Compose sets up for me automatically. Now, let's make sure I save all this stuff. The other thing that it does is when I right-click and add that Docker Compose orchestration for me, in my debug option, now it gives me this Docker Compose option. So if I go ahead and F5 this, what it's going to do is spin up both of these containers for me as we're running and waiting. It's created our web API. Oh, Barry would be very happy. Yes, I want to do my SSL. I will trust my certificates. It's going to ask me again for my other project. There we go. Yep. Yep, we do. Okay. So now it's going to run those, and I should launch our application here in a second. Perfect. And of course, it launches on my other window. No, don't destroy those. So here's our web API. Perfect. And one of the things I want to show in Visual Studio, if I can get my Visual Studio window back up, there we go, is down in Visual Studio now, we have a Containers tab for my web API that shows me all of the ports that are running. I'm going to try and do Zoom. Let's see if this comes up. I always fail at Zoom. There we go. You can actually see the environments and the ports that are all running inside of the container itself. Now, I can't get out of that. How do I get out of this? There we go. So if I go to ports, here's the ports of my web API running. I can see all the logs that are currently running out of that actual container. And another awesome thing is I can actually go into the container itself and look at the app files that are running inside of the container and actually see those files running, which is really great. I can go to my web front end, go to the ports that are there, and if I click on this port here, it'll actually launch the application. Was it running there? Let's go to the other port. Let's try our SSL port. And that one is failing. Probably got my cert wrong, but that's okay. But we can hit web front end. There it is. Sorry, I was running 2 instances of web front end. There's our application, and it's actually hitting our web API. But now I'm able to see everything that's running inside of the actual container. Better yet, if I go into my application here, I can actually hit breakpoints on the web front end. And if I go to my weather forecast controller and then hit breakpoints here, go over to my application, and we hit refresh. It's waiting. We hit our breakpoint on the front end. If I F5 this for the request, we hit our breakpoint on the back end as well, running all inside the container, all inside of Visual Studio, which is pretty cool. All right, so those are some of the tools that we have just inside of Visual Studio, when it's great. And we're just continually hitting our breakpoint, F5 a lot of times. So that's a really good feature, just when you're talking about working with containers and those microservices inside of Visual Studio and .NET, all right built in to Visual Studio, which is super great. But let's go back to the slides. But let's take a larger example. So here's an example of a more realistic microservice application. This is a bike sharing web application. And as you can see from this particular application, there's a lot more moving parts. We've got multiple types of databases. We have a React.js front end. There's .NET Core gateways. There's Node.js. There's Golang. A lot of pieces moving in here. Now, I might be responsible for only one of the parts of this particular application. For me as a .NET Core developer, maybe on a larger team, I might only be responsible for something like the reservation engine or maybe the API gateway. Now, there's a lot of benefits to microservices development, but there's also a ton of challenges. How do I test and debug my one particular service that's here? What if my machine is not capable of getting all of these services running due to maybe like RAM constraints? Maybe I have a limited laptop. How do you satisfy all of the dependencies during development time so that you can be confident that the code that you're running and writing will work as expected in the context of this entire application? If I make a change to my reservation engine, how am I sure that I'm not going to affect the billing service, the front end application, the user's service, and things like that? Maybe I do know how to run all of these languages. Maybe I've got friends that are close to me that we're collaborating on this in a really good environment. But if I do not know how to run all of it, and I can get it all running on my machine, maybe I have a monster 32-core machine. It causes distractions, and it leads to tracking issues in other items, and it gets me away from the task at hand. So as our teams were discussing with customers on what's the best way for doing this, we started to look deeper into better ways to kind of focusing developers on doing just that particular task. Now, one of the ways we looked at this was from a development approaches perspective. Now, I could just write my code locally. We've seen some examples of that throughout the conference today, and just firing everything up in containers. And I could do mocks and stubs and do Docker Compose like I did in the previous example. And that's great. I can see all of my changes immediately, see them in a specific environment. And that's fast, and my local development cycle is pretty quick. But the fidelity to a deployed environment, I'm really not sure. I can't get a good level of confidence on how fast, how that's all going to work in my deployed environment. I might feel okay, but say if it works on my machine in containers, it's probably going to work in a deployed environment. As we start to add more and more components to the particular application, as you saw in the diagram, if that scales to, we add customer services and accounting services and things like that, I obviously can't get all of that stuff running on my machine and have a great deal of confidence that I'm not going to break the build. And the ease of use of all of that, maintainability and a concept count, obviously, there's not a great deal of success to that. The next option is remote. We have a product called Azure Dev Spaces, GA last May, that allowed us to write code locally and kind of do some file syncing and push and work in kind of an environment, develop locally, push, and see those things happen on a sync basis. And Scaffold is another tool that's very similar to that. This allows us to satisfy some of the fidelity when it comes to seeing how that runs in a deployed environment, and see how, as we scale those number of application components, we really don't have to deal with that. But when there's problems, when things break, which is where I like to focus on a lot of customers, that really starts to break down. Deployments fail, file syncings fail. We get caught up in that, in the knowledge of things like Helm charts, deployment concepts, that really, we lose our focus on productivity. And that inner loop development velocity can really slow down, even though things like scaling issues are solved. So there's a trade-off. Where we kind of got to from that is a hybrid approach. And this allows us to write code locally and satisfy those application requirements by connecting to a deployed environment, to a specific service, writing the code locally, and then running everything in that deployed environment. And this kind of gives us the best of both worlds. Ease of use. All I really have to worry about as a developer is just writing my code for that specific service and being able to test all those other dependencies in that deployed environment. When I say deployed environment, I am not talking about production. Please quote that. I'm not talking about working on code in production. This is a deployed environment like a development cluster. This allows you to write and run and debug your code locally, but again, leverage that deployed environment. It's easy to use. The only thing you really need to understand is how to access the cluster. What is my kubectl configuration, and have that running, and that's great. And what this is called is, what we're calling is local process with Kubernetes. It allows you to run and debug that code in your development computer while still connected to the cluster with the rest of your services. In the example of that BikeShare microservices application, where you've got a ton of interdependent services and databases, again, trying to replicate that all on your local machine is super hard, or could be very hard if you don't have the knowledge of how all that works. It allows you to focus just on the one service. Additionally, building and deploying your code to the cluster for each code change over and over and over again can be slow, time consuming, and also difficult if you're trying to kind of debug or connect debuggers to it. We've got what I'll show next here is in Visual Studio, also in VS Code, we've got extensions that allow you to basically connect to your cluster and debug and write your code locally, but also as requests come in, as you can see on the slide here, we will route those requests to the service that you're working on with all the other ones that are actually in the cloud in your cluster. It works with the existing applications that are deployed, and then when a session starts, basically by hitting F5, we will work with the DNS on your machine and make those connections to the cluster and replace the running service when it starts. So again, looking back at the BikeShare microservices application, what we're going to do, the request comes in, goes to the front end application, and I'm only going to be responsible, as I mentioned, for working on something like the reservation engine. The request will come into the front end, goes to the API gateway, it'll hit the bikes service, and then when the request comes into the reservation engine, it'll actually get routed to my machine. I can actually debug the code, walk through it, and then continue on, and then the request will kind of be routed back out. And that allows that microservice code to run just on my machine and kind of give me just the ability to write just the code that I'm interested in writing on, and not really have to worry about how all the other application runs, let those other teams focus on their work. So let's see what that looks like. So what I'm going to do, first off, is make sure everything is running up in my cluster. So if I look at my current AKS cluster in the cloud, you can see here that I've got the web, the billing, all the databases for Mongo and SQL and everything else, reservation engines, et cetera. It's all running currently up in my AKS cluster right now, so that's awesome. I'm also going to check my services to make sure that my IP address is all good up there. And okay, we're good there. All right, so I'll close that out. let's go to Visual Studio. Let's stop this service. We don't need you anymore. And we're going to go over to app. So what I've opened up is just the reservation service here. And over in my, I believe it's in my bikes helper, yeah. What I'm going to do is I want to reserve, check the reserve bike message here, and just debug this logging message and make sure that the request ID and everything is getting logged properly. So what I'm going to do is I'm going to right click and look at the properties of my project. And in the debug here, my profile is local process with Kubernetes, right? So when I hit change, I've already set mine up. It's going to select a subscription. I've got my subscription up in the in Azure. I've got 1 million of them, so I'll check that one. It's going to say what Kubernetes cluster do I want to work on. What's the namespace? And I have my own namespace here called dev. And it's going to ask me what service do I want to work on right now. And I'm going to choose my reservation engine. And then it says what launch profile do I want to choose. And that's the launch profile. And then this is the ingress that gets set up as a part of our product here that I'm going to launch my browser. That's the endpoint that I'm going to hit for my initial request. Basically, that's the launch URL that gets launched when I hit F5. So I hit OK there. We're going to go back to our bike helper, make sure we've got, yep, that set here. So I'm going to hit that. I have a couple of windows I'll drag over here. So it's connecting to our service right now up in AKS. There we go. And it's going to say, we need to make sure it's OK for us to mess with your DNS. Say, yep. And yeah, go ahead and make the change. It's fine. This might take a little second. There we go. And let me drag this window over here. This should kick up and show all of our services running. So there's our bikes helper, our billing helper, there's the Mongo services running. This is coming, this is actually standard out that's coming from our cluster. And there's our key management service. And there's our reservation engine. And yeah, all right, there we go. And here's our actual current ride. Should be able to hit the actual front end. There we go. So it looks like I've got a bike already there. So I'm going to return my bike. Did I click that right? Oh, confirm my return. Yeah, everything good. All right, so I should be able to, let's rent that bike there. For some reason, we're not hitting our breakpoint. There we go. All right. So now I've hit my breakpoint on my local machine. It's routed it down here, and I can go into my locals. And I've got my request ID. Look at the origin request. And I'm able to just kind of debug, and I can just F10 through this stuff, which is awesome. And if I look at my reserve bike URL, there we go. So now that's HTTP bikes API. You can see that right here in red. That's not localhost. That's actually the container DNS that's looking for it in the cloud. So that's actually come from the endpoint in AKS. It's routed down to my machine. And for this particular service, I'm able to debug this and then go ahead and F5 through it. Looks like I hit, there you go. And then it goes right back up here and it says you've rented the women's cruiser owned by Fanny Melton. Awesome, thanks so much. And I'm able to return that bike. And all those other services are actually currently running in AKS. I can confirm the return. It was an easy pickup, awesome. right? And it's actually got all of these other services running all within the cloud. I can choose another one if I like, hit that random bike, and able to hit that breakpoint in the cloud again, which is super awesome. All right, let's go back to the slide and present. All right, so we were able to connect to the cloud and debug that service all in Kubernetes. I did not have to fire up all of those services in containers and run them on my local machine. We have the same capabilities within VS Code if that is your IDE of choice or your editor of choice. One of the other future things that we're working on right now is increasing your confidence in the pull request. So as I'm making code changes in that reservation service, typically it consists of code diffs, limited to team members who only have the context, and also minimum visibility. We're calling this kind of PR flow 2. So what I can do now is make a code change, check that in, and through GitHub Actions and through dev spaces here, it'll actually generate a specific URL to my pull request in that context and create a place within the PR there for somebody to come in and review the entire application running in the context of my pull request. So they can look at it, run through that, test things visually, and make sure that everything is great, and be able to do that merge prior to actually taking effect. So it allows them to review the code in my context of making that change as if they were running the code on my machine with that kind of specific URL, which is really great. The roadmap of where we're going with this, where the team is going with this, is local Kubernetes support, being able to run this same type of extension on Docker Desktop, Minikube, kind. Doing some developer-specific routing, kind of working in isolation. The PR flow V2 that I just talked about. Pod identity, service endpoints. We don't currently support service mesh right now, but they're also working on that. And that's what I've got right now. I appreciate you joining the day. It's been a long day for everybody. It's a long day for me. I've got a lot to consume myself. There's some links to the 2019 and Docker tooling demo, as well as the local processing Kubernetes walkthrough there. If you have any questions, reach out to me on Twitter now, later, any day with the hashtag .NETConf. And I appreciate your time today, and as always.
Hey, we have a question.
Perfect.
I got it up showing right now and say, are these microservices debugging tools available in the VS Community Edition? You know, since we have different flavors of Visual Studio, is it across the board, or do I need a special flavor of it, or how does that work?
Yeah, that's a great question. I believe the Docker tools are available in Community Edition. I pretty much run Community Edition most of the time. In fact, let me look right now. I am running Community Edition right now. I run Community 2019 Preview. So everything you saw today, I was running in 2019 Preview.
Perfect. So that means that, you know, you can just download it and then have the tools installed and be off to the races.
Yeah.
Perfect. Well, that was literally the only question that we had. So
perfect.
So that's good. You did it. Yeah, great job in the demo. Actually, there was a comment I would say from Cecil saying that you need to use the HTTP client factory. So that's just yes. Him.
I knew somebody was going to pick on me for that. Yeah, and I meant to mention that as normal non-Hello World demos, you would use client factory for making a call, but yeah, in my 25-minute demo, I didn't have time to do that.
Right. So tip of the hat to Cecil for looking at that. It's like, wait a minute, we can do better than that.
Tell Cecil I'll be sure to review his dapper demo and poke at him for that. So thank you.
That's right. And this is why we are all good friends.
Yes, exactly. Thank you.